one is a little bit more complex. We're going to have to set up our picture again, but we're going to solve this one a little bit differently. It says the captain of a ship wants to determine his distance from shore. Seeking a familiar landmark, he finds a 90-foot high lighthouse on top of a cliff. He sights both the top and the bottom of the lighthouse. The measures of the two angles of elevation are 46 and 39. How far due to two significant digits is he from the base of the cliff? Okay, first off, let's work on drawing our picture. We've got our water, because we have our man on his ship. And he's looking up at a lighthouse, which is on top of a cliff. So let's say this is the cliff. And he's looking at a lighthouse. Kind of looks like a lighthouse. And he's looking at the bottom of the ship, the bottom of the lighthouse, and he's also looking at the top of the lighthouse. He can see both of those. So one of my right angles is obviously bigger than the other right triangle that I have. So I have two right triangles here. One of them is looking up at the bottom of the lighthouse. The other one is looking at the top of the lighthouse. And I have two angles of elevation. Let me extend my line here. So there's my triangles. Let me fix this. Not a very good line. Close enough. Okay, we know that this angle is 39 degrees when he's looking at the bottom of the lighthouse, but when he's looking at the top, that's 46 degrees. So there's two angles here. The smaller one is 39 degrees, the bigger one is 46 degrees. What we also know is the lighthouse is 90 feet tall. But we don't know how tall the cliff is. So we're going to call that H for height. And its total height would be 90 plus H.